In this video, I'm going to show you how you can create your own character controller that works with our ledge detection and navigation system. The purpose of this video is basically to show you how you can, how the system can work with your own custom implementation of your character controller. The character controller that we're going to create is going to be very basic, very simple, and just the point that we are going to focus on is mostly kind of hooking it up to our ledge agent and detection system. So I've already created a very basic scene here. It's just a capsule with a character controller, which Unity's character controller, a very basic plain implementation of a character controller to utilize the character controller. We have a ledge that is in the ledge layer, and we have this plane as our board. I'm going to position board. And yeah, let's start. Let's see how this character controller can work with our ledge agent. Let me open the character controller class. As you can see, it's a very basic character controller class. Now, the first thing we want to do, we want to add the ledge agent class to it. Ledge agent is a runtime script. It does, a lot, but again, it's something that you can customize and have your own implementation of it. But I recommend you use the existing one to start to get to understanding how it works. And then after that, you can go ahead and create your own version if you want. So let's see, if you try to add the ledge agent, it's going to complain. It says like, hey, there are some required components that are missing. And what is the required components that are missing? It's if you go to ledge agent, it requires an implementation of iLedge move request processor, an implementation of a iCharacter transform, and an implementation of character state. We already have an existing implementation of this class that you can reuse. I recommend you using that. It's called player ledge move request processor. What it does, it basically it listens to position updates sent by movement module, so the agent can move on the ledge. And this also takes care of hand position updates. That's why you will see this moving side first and all that, which means like, if you're going to the right, it's your right hand that moves first. And if you're going to the left, it's your left hand that moves first. We are working with a capsule here, so you don't really need this, but this works just fine. We just might need to tweak some data to make it so that it's smooth for our purpose here. The other two implementation interfaces that needs to be implemented, these are very much related to how you create your character controller. So that's why we will implement these interfaces here. So if I go here, I'll have to implement iCharacter state, and I want to implement iCharacter transform. So what are these interfaces? If you look at the iCharacter state, it's just like the ledge system needs to know, are you grounded? What is your move direction? Are you planning to drop here? These are for the movement modules to be able to get information from your character controller. And if you go to character transform is mostly positional information and directional information about your character controller's current position, basically. So that's why they are very correlated to how you create your character controller. Like for instance, here we are using Unity's character controller, and our collider is just a capsule collider. So that's why, we will have a certain implementation. But if you're using a different type of objects, or is it a ragdoll physics? Are you using a cube for your controller, for your collider? That's why we don't have a concrete implementation for it in this asset, and we leave it up to you how to define it. And I can show you that it's very basic implementation. They are very, very easy to implement. And all of them are here. So I'm going to go like quickly and implement each of these, and you can see that, you know, why, like you can see that they are easy to do. They're very self-explanatory, let's say. Set collider dimension and reset collider dimensions are again for when we change the capsule height for brace and, you know, free positions, and we're not doing that. So as you, I think you noticed that I didn't implement this because we like jump on ledge requested needs to know whether we are on a ledge or not. So what I will do is that I will add the a reference to ledge agent. Ledge agent, and then we're going to go in this start method and say ledge agent is get component ledge agent. So now I can implement this. I can say that ledge agent that is on ledge, and we get a jump space. All right, so now we implemented that our interface is there. We have a proper implementation of our interface. We might have to come back and change the stuff if we see something is not right. But for now, I think we are going to be able to now go ahead and add our ledge agent. Yes. So as you can see, the ledge auto movement handler is also added. That is a required component for ledge agent. So because it's a concrete definition, Unity is able to add it on its own. You don't need to add it by yourself. So now we have our ledge agent. So what it requires is these two very important data. One is detection data and one is the agent data. Detection data is basically any sort of like all the properties, all the characteristics of a valid ledge and how an agent, you know, character should be placed against this ledge. So let's create that one. Ledge detection system, ledge detection data. I'm going to call it capsule detection data, and I'm gonna add it here. Let's see what does it have. So as you can see, it has quite some, you know, a few properties. Most of them are about how a detection should happen and where should be the positioning of capsule or any collider that you have. Basically the placement of a character transform against this a potential ledge. What we need to set immediately right now is the grab layer and climb layer. The grab layer would be ledge. We want to be able to grab onto ledges, and climb layer, we want to be able to climb ledges, and we want to also be able to climb up on top of, like, you know, if the surface that we're going to climb on is not ledge and it's the word or any other layer that you decide, we want to be able to climb onto those as well. We will leave everything else as is. We will come back and modify them if we see that they need to be modified. The other data that we need to create is a ledge agent data. I'm going to call it capsule agent data. This one has more information, but these are mostly about anything after a detection. It's movement, it's about the speed that you kind of like land on a ledge, whether you, like, you know, for detection there is information here, but it's mostly, you know, like how high or low these two, like basically how much below a ledge do you want to be able to detect the ledge. That's like, you know, again, these are they all have tooltips, so you can read what they do. I can set a few properties already here. As I said, the capsule height, changing capsule height is only matters when we want to handle, like, brace position and free position. In this capsule, we're not going to do any of that, so I can just disable this. And then there is the hand movement speeds. So we have right hand on ledge speed when it's braced, left hand, like our capsule is not going to have hands, so we can just make this like a kind of a high value, so they get processed very quickly, so we can go immediately to the body position updated. One thing also you can do is, if you have your own implementation of this class, player ledge move request processor, this one specifically handles hand positions. If you have your own implementation of this that doesn't care about hand positions, then you can leave those values as is. They're not going to be processed anyway. So let's go back to our data. So we did create an agent data. Let's just go see if it set everything. The only thing we didn't set is the obstacle layer. It doesn't matter in this test because we're not creating a complex geometry for our for our scene, but I will just put word as like a obstacle. All right, so now we have everything here. So everything seems good in terms of our character controller setup. We have implemented the interfaces that are necessary for Ledge Agent and other modules to work. All right, so right now our Ledge Agent, basically our character, is set up to be able to work with ledges, but we don't have any logic here. Like, for instance, we don't have the detection logic. So let's go ahead and add that. That is a module, so we can go to ledge detection or detect ledge move. That's the module for detecting the ledges. If we run it right now on its own with just this added, we will see that the ledge is detected, but we might not have the result that we think we should have, So, okay, yeah. All right, so what happened here is these gizmos here, they are indicator of that a ledge is detected and the ledge is valid, because we have hand positions, we have climb positions, we have contact points. Every information that we need is there, but we are not on the ledge. That's the reason for that, is because we are not really doing anything with that ledge. The ledge agent is telling the character controller that the ledge is detected, but we are not doing anything with it. There are a few ways that we can handle this. The most simple and easiest way would be to just basically tell our character controller that if ledge agent is on ledge, then don't do anything, just return, and don't do, like, just leave it be, don't do anything. That makes it so that the character controller is not gonna handle the movement, and it's gonna just say, oh, I'm on ledge, no movement. All right, so let's see. All right, great. We are detected, the ledge is detected, and we are put next to the ledge. But there is nothing we can do right now. We can't climb, we can't jump, we can't do anything, and that's because they each of those, they have their own module that needs to be separately handled. So let's go ahead and do the drop. So when we jump, when we detect a ledge, then we can drop from the ledge, so we're not stuck. The first thing that we need to add is the movement for it. The movement module, drop from ledge. It's another movement. And we basically have already defined that by pressing C button, we are requesting a drop. Is drop requested? We are saying that that's with the C button. So right now, if I go and try to drop from the ledge, we will see that we might drop. Okay, a few things happen that needs addressing. First thing, we did drop. We did a hop before dropping, which I know what is happening, but the ledge is still there. The previous ledge that we were on is still there. So let's go and address all of that. So first things first, why did we hop up? It's because here when we are saying, okay, if it's on ledge and just return, we need to get our previous velocity and set it to 0. Velocity equals vector3 dot 0, and that should take care of us not doing the hop anymore. Yeah, all right, so we fall, and okay, but there is a problem. Based on systems like understanding, the ledge is still there. There is a valid ledge that the character hasn't unsubscribed from it. He hasn't left it yet. We need to tell the ledge system when the ledge needs to be left, and like we are not on a ledge anymore. So that's why I can't attach to any other ledge yet, because based on systems understanding, I'm still on the ledge. This is where the concept of ledge phases comes to play. So if you look at the ledge agent, let's explore ledge agent for a little bit. Where is ledge agent? Ledge agent. Ledge agent has the access to a property called ledge context. Ledge context has variety of information that are all useful and they are used, but the one that we want to look at is the ledge phase. Ledge phase is an enum that can be in none, which means that we are not on a ledge, idle, landing, we are landing on a ledge, moving on. They're pretty self-explanatory, but the thing is that each these phase changes, the change is broadcasted, and the player controller, like you as a developer who's working with this player with your character controller, you need to handle how these phase changes should be handled. For instance, right now we are changing from idle to dropping, but we are not doing anything with it. We are not invalidating the ledge. We are not telling the system, okay, like when should I be done with this state and go to none, like all of that. This is the reason that it's like that, is because we can't predict how people will implement their character controller. If you use our example character controller, which is the class player controller, then everything is taken care of. You can expand on top of it, you can add your own logic to it, but everything is taken care of. Phase changes and like they're responding to animation and all of that. But that's not the purpose of this video. The purpose of this video is to let you know how you can create your own character controller. So let's do this dropping phase together. There are multiple ways to do that. So one way you could do it is to go say ledge agent.onContext changed. I want to do XYZ when the phase is landing. I want to do this and that. And that's perfectly fine. You can make it work with that implementation. You are free to do that. But our example player controller is working with a certain architecture. So just so you understand how that one is implemented, in this tutorial I will do the same. So what is going to happen is now in the movement we have added the drop, which changes the phase amongst many other things, but it changes the phase from idle or whatever phase it is before to drop. So now we want to add a reaction to drop. So I will call this, I need to create a new class. I will call it capsule drop reaction, and I will add it to my base class that contains my character, that contains my ledge agent and contains my character controller. I will add it to the top base game object. So what would it do? It would implement a base ledge move reaction. And as soon as you start implementing that class, you need to implement these abstract methods. You don't need these. Okay, so in which phase should this work? We already have said that we want it to be on the ledge phase dot dropping. And how we want to react, we will decide that shortly, but let's just see what this class does. So it's a base class that has a reference to an agent and transform. It gets the component in parent, but it's going to work just fine if it's in the base class. It listens to, by default, it listens to the onContext changed, and based if the phase matches the phase that it needs to react to, it does react to that class. So it's very basic, it's very simple. But what do we want to do to react? For the drop, basically what we want to make sure that the ledge that we were on is invalidated or reset in an appropriate time. You can have it as complex and as robust way of calculating that as you want. It's like basically you have a free range here, do whatever you want. But the most basic way that I would do this is to just wait a few seconds and then re-enable the basically, and then reset the ledge. And the reason I need to wait a little bit is because if I do that immediately and just invalidate the ledge, as the capsule is falling, it's going to detect the same ledge again. You need to guard this with some timing or some guard rails, whatever you decide. For this instance, because it's our very basic and simple character controller, I will just wait for a few seconds. Wait and reset ledge context. I will yield return new wait for seconds. And how many seconds? I think we already have exposed agent data dot drop something to do drop delay after drop to look for another ledge. And then after that, I will say agent dot reset ledge context. And then here I will just start the enumerator, start coroutine, and wait. If I can type. All right. That's perfect. But I think we need to, there is something that we need to do. Here, if you look, there is a method called initialize, and it's in this initialize that we do this. So the initialize needs to get called from somewhere. You can go in your capsule character controller, and as soon as you start, you can say for each var reaction in get components of type what was it called? Base ledge move reaction dot initialize. The reason I'm doing a for each is because there is more than one. We will add more reactions. This is like a more reliable way of doing this. So now what we need, we added this there. So let's and let's see if the drop works. Oh, okay. We have a problem. And I think you guys can tell what the problem is. The problem is, if you can see that for a very short, like almost a frame, the detection logic kicks in and detects the same ledge. I did mention that we need to wait a few seconds before we start detecting a new ledge. So we can go in ledge agent data, and what is the drop from ledge delay? Like delay right now is 0.35 seconds. We can increase that and it's gonna work. But I think there is a better solution here, because I feel like this capsule is a bit too high on the ledge anyway. Like it's just sitting way too high on the ledge. Like imagine if that's your character, like, you know, the head is going to be here, like, you know, the body, that's the body. Like it's a bit weird. That's not usually how ledge traps work. If you want it to be this way, then you can just go ahead and increase this and it's going to work. But I think what's like the better way is to go to ledge detection data. So we can increase this value, like if you put it for 0.75, then what will happen is that it's going to pull everything down a little bit. Every detection, every like position calculation, it's going to just pull it down. So right now, if it drop, now it's like we are there. We are now lashed to that position. And if we drop again, then like that problem is not going to happen. So just to reiterate, with that, with tweaking that value, which was in a detection data, ledge edge Y offset, by increasing that value, basically we are like the placement of the agent goes lower. So makes it so that when that duration of 0.335 second passes, then the same ledge is not able to be detected again. All right, so that's the drop, and we created it with a reaction class. We can do now climbing the ledge. So in the movement, I can add climb and jump climb ledge. Now let's create the reaction class for that. Capsule climb reaction. Now let's implement our jump climb reaction, which is a base move reaction, and it doesn't need a start or update. We will implement the methods. The ledge that the one that we want it to react to is climbing, and how do we want to react? So here's where the auto movement handlers come handy. So basically what we want to do, auto movement handler classes, which is in ledge agent. If I go here and ledge agent, we have this auto movement handler. Auto movement handlers basically, as the name suggests, they just create a sequence of movements. So basically for this capsule collider, what I want is to move up vertically and then move forward to our climb position. And in that point of the execution, our climb position is previously calculated by the system. So I'll show you how simple it is to do that. So we access the auto movement handler. We're going to say add to targets. And what this method receives a list of target locations. Target location. My first target location is just moving up horizontally to where the climb I want it to be. So here I would say transform here I would say my position that I want to go to is a new vector 3. The X would be transform.position. The Y would be this context, ledge context dot current ledge dot center ledge dot climb position dot Y, and the Z would be my transform.position dot Z. That would be my position, and rotation, I'm not changing rotation at all, so it would be my transform dot rotation, and my movement speed would be I can expose a variable here that what would be my movement speed. I'm going to say public float move up speed. I'm going to say 4. I'm going to change it if I'm unhappy with it. That would be my move up speed. Let's make this position.x. So now we need to add our second target, which is our horizontal target. Position is a new it's going to be ledge context dot center ledge dot climb position, current ledge center ledge dot climb position, and we will move it up a little bit so we make sure that it doesn't clip into meshes. and we have exposed a property for you to use, ledge that's and then for rotation we same the rotation, and move speed we also have exposed a variable agent data dot forward speed dot climb. Now the very useful feature of this auto movement handler is a callback that you can say on target reach callback is, what do we want to do? There is a method in ledge agent which is disable auto ledge climb. You can just call that and you're good to go. So now if you go back to our class, our Unity, you will see that we are able to climb the ledge and grab onto it again and drop and jump, and we can't move yet and jump and climb, and beautiful. Okay, so now we can go ahead and try to implement the moving side to sides on the ledge. That is probably going to be the most interesting one. So we do need to have the movement module for it. So this one is a little bit different than other movements, because although you are able to implement it with move handlers and the auto move handler, this uses the class that we earlier added, the player ledge move request processor, because primarily this is made to work with animation and IK and you know, like limbs and all of that. So that's why it just is handled completely differently, but it's still pretty simple. So I can show you exactly how it is done. We've added the module. Now we just need to adjust our controller. One way to do it, again, since this is somewhat different, you can like, we're gonna implement it differently. What we need is for in the start to start listening to some callbacks. We will start to listen to ledge agent dot movement processor move request processor dot on body location updated. It's again, because we don't care about hands, we will add a method and we'll name it on body location updated. What it receives is a position update event args. We're going to say event args. What does this event args contain? It contains position, rotation is right hand. That's pretty much it, I think. Yeah. So we can just say transform.position equals event args dot position, and transform.rotation equals event args dot rotation. We subscribe to this, and then on destroy we will unsubscribe from this. You can also implement it in a reaction class, but this is like really all it needs to do. So even if you make it in a reaction class, it's like, it just doesn't make much sense to be a reaction class. It makes sense for it to be its own thing. So if we run this as is, we get this error, and this error makes sense because what we are doing is we are listening to this event callback from the move request processor, which is property of ledge agent, and that might not have been initialized yet because that also happens in the start method of the ledge agent. We set the move request processor. So this sometimes works, sometimes does it, but we can't really deal with this unreliability. So you can define your start class as an enumerator. So what I will do is just say yield return new wait until ledge agent dot move request processor is not null. Then this is going to work, and you should not get exception anymore. And again, this sometimes, like, you might not get that error, but it's still, that's not reliable. And we are stuck, we are in the ledge, and we can move. The hand positions are updated, the player is moving, all of that. Now, if you want to like move faster or slower, that's something that is in the agent data. Move on ledge speed, brace to free. For the default behavior is always the braced, so you can just go here and like, if you change it to 3, then we're going to move faster and so on. And we can drop, we can jump, we can climb, and perfect. I hope this video was informative enough for you to get you going and get you to start creating your own character controller and take advantage of the system. And please let us know in the comments if you need any part of this tutorial needs more work, or you have questions. You can also join our Discord and join the discussion in the information about the Discord is provided in this video's description. Yeah, and I hope you make great games using this system. Thank you.